Our sample calculation we're going to look at here involves two protons, which have a positive charge, like so, and we are told they're separated by 1 meter. When released, what will their forces and accelerations due to the electromagnetic force be? Well, the electrostatic force is K, Q, little q, over R squared. And our K is 8.98755. 8.98755 times 10 to the 9th. Now, the charge on a proton is given in coulombs, and that number is 1.6 times 10 to the minus 19th coulombs. One elementary charge is 1.6 times 10 to the minus 19th coulombs. So we have one proton, which is 1.6 times 10 to the minus 19th, and another proton, 1.6 times 10 to the minus 19th. Now, of course, in this case, we don't see one as a larger charge or the other one is larger than the other. They're both the same. And as we've said in the past, commutative law of multiplication, it doesn't really make a difference. And the distance between them is 1. Oh, that's awfully nice. Well, as our process is, we bring out our numbers, 8.98755 and 1.6 and 1.6. And we have 10 to the 9th and 10 to the minus 19th. 10 to the minus 19th. And the denominator is 1. So doing a quick estimate here, this we would say is 9, and this is 2, and this is 2. So 9 times 2 is 18, times 2 is 36. So we're looking at like 36. 10 to the minus 19th and minus 19th is 10 to the minus 38th. Plus 10 to the 9th would be 10 to the 29th. So we're looking at about 4 times 10 to the, as the minus 29th times 10 to the minus 30th newtons. That's what we should get when we do the whole thing out precisely, which we can do next. .01. So instead we get 23 times 10 to the minus 29th, 0.01, which is 2.3 times 10 to the minus 30th newtons, the electrostatic force. So that's how we find the electrostatic force. What will the forces be? Well, now the question is, what is their accelerations? Well, what we know, if we look at proton number 1, it's going to experience a force of repulsion in that direction. And the other one is going to experience a force of repulsion in this direction. And so the force, we know the net force it's going to experience, and the net force is ma. So the acceleration will be the net force divided by the mass. So we have 2.3 times 10 to the minus 30th newtons, and the mass, which is 1.67 times 10 to the minus 27th kilograms. And if we do an estimate, I'd say this is about 2 and this is about 2, so that's 1. So we're looking at an estimate of about 1 times 10 to the 3rd meters per second squared. Whoa, 1,000 meters per second squared, a kilometer per second squared. That's pretty astounding. 1.377. Or about 1.4 times 10 to the third meters per second squared. That is the acceleration. That is an incredible acceleration. So even at a meter apart, that's from your fingertip to maybe the center of your chest is about a meter, or a meter is a little bit less than that. Place those two protons there. The force of electrostatic repulsion is so great it would accelerate at 1,000 meters per second. So next, we want to find out, in this next thing, we are going to make it, in the next part of this sample calculations, we are going to compare this to the gravitational forces of attraction.